Okay.
Fine.
Go back.
Let me go ahead and welcome everyone
Okay.
to the fourth in series of the ASCE Spring Seminar. Today we are presenting Davin, who is a graduate of the University of Toledo in 1987. He has 33 years of professional experience in managing, designing, and reviewing highway structures. As the principal and chief bridge engineer of GPD, he has overseen over 300 projects ranging in construction value from $50,000 to $200 million, and is qualified as an ODOT Level 1, 2, and 3 bridge engineer. His extensive experience also includes working with contractors to provide construction engineering designs such as preparation of erection plans, bridge demolition analysis, shoring designs, and jacking plans. In addition, he has managed and performed over 20 value engineering revised designs for contractors and over 40 design build projects in the past 20 years, totaling over $100 million in construction. As always, if there are any questions, please use the chat function. We'll relay them to Davin as soon as I see them. PDF certificates will be available at the end of this week as we completed the 6 seminar series. Thank you very much. Thank you, Davin. Please go ahead. Thank you.
Thank you, Payman. Thank you. Can you get okay?
Yeah.
All right. Well, I assume everybody. Okay. Well, the project that I'm going to present to you today is about Columbus Crossroads Phase 4. GPD was selected by District 6 and Central Office to perform the engineering design service on this project back in 2012, which is about 8 years ago. And yeah, these sections of I-70, 71 through downtown Columbus consistently rank in the top 5 location for Ohio crash and congestions due to the interweaving closely spaced between the ramps and also insufficient accelerations and deceleration lanes. The multi-phase of this project will eliminate the weaving on I-70, 71, from the exit and entrance ramp, as we all experience, improve the safety, which is very important, and add freeway capacity and enhance the freeway aesthetic feature and allow full utilization of the infrastructure. And yeah, the Phase 4 consists of 2-mile sections of I-70, 71 right here to be widened to 10 lanes, which is 5 lanes in each direction. And 4 consists of 4A, which is the purple color here, and 4B, that is in green, which is just east of High Street, which is, you see on the picture below, anything east of High Street up to 4th Street, they are 4B. And due to the funding constraint, ODOT further divide project 4 to smaller project like 4R, 4B, and 4H. And the 4A basically start from Southern Avenue all the way, across the Scioto River and all the way down to High Street. And right now the 4R, which is the ramp, as you can see, right at the south side of the existing eastbound freeway right now, this is the ramp. This will be anticipated to sell in October 2020. Actually, it's supposed to sell in April because of the coronavirus. They have to push back to October right now. And this 4R here, it is the ramp that if you're coming from the west, like Julia, or you're coming from the Grove City, if you want to go to downtown, this is the only ramp that you have to use to get to downtown. And this ramp consists of, I believe, like 7 bridges, which including the ramp C5, which I'm going to talk about this later, Front Street, and 11 wall. And Project 4A, which is the existing eastbound I-70, is from the bridge over Scioto River, which is right here, all the way to High Street. It consists only 1 wall and 2 bridges. And the one on the eastbound bridge over Scioto River, there is a major river crossing. They are over 1,000 feet long, consists of 5-span hybrid steel plate girder with 50 and 70 KSI steel. And 4B, just like I mentioned moments ago, is only half-mile sections and extend from High Street to Grand Avenue. And we work on 4th Street, which is right here, and 3rd Street, and provide a very, 3rd Street also got a cap just like High Street. And High Street basically is a bridge with a cap, which I will explain a bit more later. And for this project, there are a total of 12 bridges and 23 trench wall, but I'm only going to highlight a few unique bridges and trench wall for today's presentation. The first one, that is the ramp C5 over I-70 and 71. This is the one that if you want to get to downtown coming from west side of the city or from Grove City, you have to get on this ramp here. And as you can see, the unique thing about this structure here is the orientation of the framing plane. This beam are placed not parallel to the traffic flow. Instead, they're placed across the freeway. And we have, by doing that, we have to use 45 pre-stressed concrete I-beam. The length is about slightly over 100 foot. Even with that many beams, this framing plane layout still would save ODOT about $1 million. And we have to use the 3D finite elements program to design the pre-stressed concrete I-beam for the reason that we're concerned about differential deflection between the beam. Because as you can see here, this is the loading. Each beam are not at the same locations. And then this program, we also calculate what is the long-term camber and the long-term deflection or differential deflection of each beam. Make sure you will not crack the deck. And this is a pretty unique structure. It took us a long time to model this framing plane. And the next one I want to talk about is Front Street Bridge. The existing Front Street Bridge is a 2-lane one-way all heading north. And there's a parking on the east side. This is what it's going to look like in the future on the Front Street Bridge. The ramp bridge that I just talked about is right here. And the future Front Street Bridge will be 4-lane, 2-way. There's no bike lane, but we provide 2 10-foot 6 sidewalk on both sides. There will be, the parking meter on both sides of the bridge also. We also provide 40-foot wide landscape, what we call a arrival gate on the east side. Also provide additional 10 foot of green lawn space along the west side of the bridge for planting. And we provide the architecture, pergola, screen wall, which I will show later, and the planter to enhance the connections between Brewer District to downtown Columbus. The proposed structure will be 2-span. As you can see, there's a haunch girder, mainly because of, the reason we need to use haunch have to do with the vertical clearance issue. we cannot raise the profile too much due to existing street on both sides of the bridge. And this is the cross sections that I just mentioned moments ago. Just like to show you a few examples of the slide for comparison now and the future, how it look like at this location. This is what it is looking at now on the cars level, street level, looking north. This is how it will look like in the future. As you can see, that is the green space on the west side, and what we call a, arrival gateway, 40-foot wide on the east side of the bridge. This is now, this is future.
David, we do have a question. What software was used in the beam designs?
Okay, can you speak louder?
Yes, what software was used in the beam design?
I still cannot hear you. Let me turn on the volume of my speaker here, sorry.
The question was, what software was used in the beam design?
Oh, what software? Yeah, we use Midas.
Okay, thank you.
And that answer your questions?
Yes.
Okay. Yeah, the pier shape is pretty much identical like the one that you can see right here on I-670 near High Street, Goodale area. This is the aesthetic standard for the downtown Columbus Crossroads. And let's talk about High Street Bridge. This is the existing High Street. It is 4-lane, 2-lane in each way. They also have a I believe they have a street parking on both sides. Same as Front Street Bridge, the main objective is to enhance the pedestrian connect district and downtown Columbus. The difference between Front Street and High Street Bridge is City of Columbus request to build a 60-foot cap on both sides of High Street. And this is similar to, the cap on High Street down at the Convention Center near Goodale Avenue, similar to that. And the proposed cross sections of this on the High Street Bridge also falling two-way, just like Front Street, no bike lane, but provides 10-foot sidewalk, and also have a parking meter on both sides. If for any reason the City of Columbus cannot find any developer to build restaurants or retail, at this location, it will then turn to a green cap, like the way we've shown right here. And let's show you how few examples of the slide for comparison, how it look like at this location also, and in future. This is the area view, and the green cap on both sides. They are 6 wide. Here's a cross section of the bridge. It's a 4-lane, 2-way, parking on both sides. And this is standing on the west cap looking east. And as you can see, if you walk on the bridge, you will not realize actually there's a freeway underneath it. And this is the green cap on the east side, looking north also. And the High Street Bridge also 2-span, and in front of it, but we have to use tangent shaft on the north side or the north abutment. And the reason for that is we try to use the tangent shaft not as a permanent or temporary shoring, because this is pretty tall, about 40 foot. It's going to be very, very expensive just to construct the temporary shoring between the existing and proposed, with the tie-back, all the utility issue, and then tear it out and then rebuild this. So the tangent shaft serves as a permanent wall and also temporary shoring. This is a tangent shaft, a lot closer view. Here is the more like a pier abutment seat, the tangent shaft, and we have the precast panel placed in front of it. This is how the tangent shaft look like. Here's the abutment seat cap, sit on the tangent shaft, and this is the wing wall of the tangent shaft. And here's the panel placed in front of the tangent shaft using a tie rod to support, the precast panel tangent shaft. Pretty much this will look like a wall at the end, and you could not able to see the ugly tangent shaft behind it. And the pier at High Street, Front Street, even 3rd and 4th Street will look similar, like the one that I just mentioned there on the 670 Goodale area. Let's talk about geotechnical issue at this project. And this is also at the RAM C5 bridge. And there's an existing sanitary sewer line at the west end of this RAM bridge. The 16-inch sanitary line belongs to City of Columbus. And we also encounter very weak soil at these locations. And here is the existing sanitary line. And the green area that we have to use cellular concrete, lightweight cellular concrete at these locations. And then the brown area, we have to use geofoam. This is over the freeway. This is over the new RAM C5. And let's explain to you why we have to use geofoam, right over the existing freeway, and we don't have to use that over the RAM. As you can see, over the RAM, we able to remove a lot of existing fill, and that's why we can use cellular concrete. The cellular concrete only weighs about 30 pounds per cubic feet, and as you know, the regular weight of the soil is 120. So every feet of the existing dirt that we remove, we can place 4 feet of cellular concrete without adding any weight on this sanitary sewer line. Unfortunately, there's not a lot of existing soil we can remove over the freeway. Therefore, we have to use geofoam. Geofoam only weighs 1 pound per cubic feet. So every foot that we remove, we can place 100 foot of geofoam. That's the reason we have to use geofoam over the freeway. So, as you know, it is very dangerous to use geofoam. If any gas on top of the geofoam, it will be just melt. Just like cheese. Therefore, we have to pour 1 foot of the deep on top of the geofoam, and also put a lot of the waterproofing material to prevent the gasoline spill on the geofoam. And anything outside the sanitary line, we will put cellular concrete because of the weak soil. And I'm not just want to prove it, I'm not lying to you guys. we are using class 2 cellular concrete. It is weight about 30 pounds per cubic feet. And then the cellular concrete actually is only weight, we are using ESP is weight about 1.15 pound per cubic feet. And of the cellular concrete is just more like a grout, like low strain mortar. This is how, this is the one that we did, one in Toledo. And we did also, we have designed one in Toledo also using cellular concrete on I-75. And it is easy to install. You know, 2 guys can pick that cellular, the geofoam. Let's talk about wall. Another unique wall design or trench wall that we designed is at 4W1314 at Fulton Avenue, Fulton Street. And this is front. At the back here, at the bottom here, that is a high street. And City of Columbus want to put planter along the city street. Because of that, the sidewalk have to extend cantilever out into the freeway. To overcome that, as you can see, this is a sidewalk and the freeway is directly below. And this wall is about 40 foot tall. And this cantilever doesn't help. You know, as you can see, cantilever and also have the load offset from the wall and create more bending and create a lot of headache for us. And this cantilever, some of the area extend out more than 13 feet. Again, we use Midas software to analyze this, make sure we are more worried about deflection at the top. To control the deflection less than an inch, the diameter of the shaft on the tangent shaft is 8 foot diameter. Try to visualize how big that is. You know, the typical column, the pier column is only 3 feet. This is more than twice as large as the regular pier column that we have, you know, we have normally designed. And make it even worse that we have the underground utility. That's why you see there's a gap between the tangent shaft. So it will not interfere with the existing sewer line. This is, on this project, anything you can think of, it have all kind of utility line, underground utility line. Make us design very challenging. And this is another view. I think the space between them is about 20 feet also. You know, the blue highlight here is the P, I believe that is the abutment seat. The brown one is what we call cantilever arm. The piece that's sticking about a range from 4 feet to 13 feet up to support the sidewalk. The sidewalk is the green highlight in this area right here. And to control the deflections of the tangent shaft, we have to use what I call plate girder beam right in the middle of the tangent shaft to control the deflection. And on a couple sections of this trench, we're able to use just a typical full height retaining wall. And we also give contractor an options to use a precast if they choose to use precast. Alternate bid. And this is the precast full height, what we call precast full height wall on 4W13 if the contractor chooses to do that. And I think our wall is about good 20-some feet also. And this is a precast wall, but the footing still cast in place. As you can see, they set on the footer and then support it. Then they pour the concrete on the footer to secure it. And you can see on this slide right here. And the total constructions for project for just the bridge itself is over 108,000. And then for project 4B, just the tree structure about 19,000. And then just the wall, this is only 18, actually it's 23. I would say it's easily 47 million. And I believe the total construction cost, including everything, the bridge, the roadway, you know, and the wall is over 200 million. Any questions?
If there are any questions, it should be on the chat function. I don't see any yet.
Well, if no questions, I guess I conclude my presentation. And I want to thank everybody take the time to listen to my presentation. And wish everybody stay healthy. See you guys very near future, my friend.
All right. Thank you very much, Davin.
There are a couple questions, Payman.
Davin, yes, I do see a couple questions. It says why pre-stressed beam was used.
Okay. Yeah, you're talking about the one on the RAM C5. And yeah, because we have 45 beams, it is cheaper to use a pre-stressed concrete beam versus steel beam. Plus the steel beam, you know, not the entire length of the beam is protected by the concrete deck. You know, the expansions on the steel beam, the camber or the deflections, the movements is a lot huge due to the temperature for the steel beam versus concrete.
Davin, and how much vertical settlement was allowed behind the cantilever wall?
Yeah, typically it is 1% based on the height of the of the wall, 1%. But because this is at the downtown area, we are limited only to 1 inch.
Okay, thank you. Are there any other questions that should be relating to Davin? If so, please use the chat function.
Yeah, all are very good questions.
Allow a couple of minutes if there are any questions, and if not, I will be able to complete this session. Okay, sounds like there are no other questions. Thank you very much, Dan. Really appreciate your time, and everybody else. Our presentation for tomorrow will be our next presentation will be on June 3rd by Mike Broker on cable state bridges in Ohio at 11 o'clock. So I hope to see everyone. Thank you very much, David.
Okay. All right. Stay healthy, all my friends.
Thank you.
Take care.
Thank you. Bye.
Thank you. Bye-bye.